thick, a machine called a suction evacuator removes the unfrozen liquid and feeds it back to the filling hopper to be re-injected at the start of the line. The shells are empty now and ready for filling. The ice cream filling is made of various milk products blended with liquid cane sugar, corn syrup, stabilizers, and emulsifiers to puff up the consistency. The factory pasteurizes the mixture, heating it for 35 seconds at 80 degrees Celsius, then freezing it. Then it homogenizes the filling, skimming off the milk fat that rises to the surface. The shells are still floating in brine as they reach the filling station. The machine shoots in the ice cream, overfilling the shell a bit to create a 1 centimeter cap. The ice cream begins to harden in the cold brine. Once it reaches a semi-frozen state, a machine appropriately called the stick inserter pops a wooden stick into each mold. Now the molds leave the brine and enter a tank of warm water, 24 degrees Celsius, hot enough to detach the cream pops from the molds without melting them in the process. From initial injection to final extraction, it's been 7 minutes. The machine dips the cream pops in cold water to produce a protective coating of ice. This will keep the surface from sticking to the wrapper. It will also lengthen the product's shelf life. The machine deposits the cream pops into a continuous stream of paper wrapping. Heating elements seal the wrapper on top and between pops. Then a slicer cuts them apart. The empty molds go through an automatic wash and rinse cycle on their way back to the start of the line. These molds are for making chocolate fudge bars. The production process is the same, except that the shell is fudge flavored, made from milk solids and chocolate powder. And instead of ice cream in the center, there's chewy chocolate syrup. The factory stamps the packaging for all its frozen treats with the production date and other information. These frozen treats have a 1-year shelf life in the freezer, provided you maintain the temperature at an ideal minus 25 degrees Celsius. Few toys are as timeless as interlocking building blocks. Children can stick them together, pull them apart, and rearrange them endlessly. From large-size blocks for babies to intricate kits for older kids, building blocks stimulate creativity and improve manual dexterity. This company makes plastic building blocks. Depending on the type of block, it uses either polypropylene, high-density polyethylene, or high-impact polystyrene. These plastics arrive at the factory in pellets. Because they're naturally transparent, the first step is to color them. The pellets go into a mixer along with pigment beads made of powdered pigment in a type of plastic that's compatible with the pellets. The pigment beads make up just 2% of the weight, but that's enough to color the plastic a deep hue. The mixer feeds a plastic injection machine. It heats the pellets to 204 degrees Celsius, melting them in a matter of seconds. The machine then injects the molten plastic into molds. A system of hoses cools the molds with cold water, instantly hardening the plastic. When the machine opens, ejectors thrust the blocks to a conveyor belt below. For these blocks, the entire cycle from start to finish takes just 14 seconds. The length of the cycle varies with the size of the block. This large school bus, for example, requires more plastic, so injection molding takes 22 seconds. The wheels for the bus take 20 seconds. At packaging time, each type of block is loaded into a separate vibrating bowl. The shaking separates the pieces, enabling them to pass by an optical counter one by one. This automated counting equipment can tally up to 16 different types of blocks at a time. It can be programmed to assemble a kit consisting of specific quantities of certain blocks. Once each kit is counted, it drops into a bucket. The factory also makes the buckets by plastic injection molding, and it even incorporates the labeling right into that process. Here's how it all works. A robot takes two labels, one for the front of the bucket and one for the back. It passes a static generator that charges them with static electricity. Then it loads the two labels into the mold. The static cling holds them in a flat position while the machine injects the plastic and molds the bucket. The hot plastic